Okay, great. So this is what we've done so far. We want to calculate IN. We've said to calculate IN, we're going to work out I of B in the blue box. And the reason why that's a good thing to evaluate is that by taking derivatives of I of B with respect to B and evaluating it at B is equal to 0, we get IN. So our task now is to calculate I of B, and if we can do that, we've got IN. Now notice that I of B looks very similar to I naught. And I just want to tease that out a little bit right now, okay? So I'm going to plot here. So let's make a plot. And on this axis over here, we'll have X. On the vertical axis, I'm going to consider two things. So the first thing that I will consider is minus alpha over 2x squared. What is this? This is just a parabola. And that's always a negative value, except at 0, where it's equal to 0. So we get a parabola that looks like this. And that should be symmetric about the vertical axis, just a normal parabola. The other thing that I want to plot is, and of course, this is just the exponent of I naught, okay? So let's maybe track that. So this is the exponent of I naught. I also want to look at the exponent of I of B. Now, what is the exponent of I of B? Well, it's minus alpha over 2x squared, but then there's a plus bx. So if you look at this, well, when x is 0, this also passes through 0. But then for very small values of x, very, very small, the first term vanishes, or the first term is much smaller than the second term. The second term is positive. So it means this blue expression actually becomes positive for small positive values of x. And what it looks like, it also looks like a parabola, but it's been slightly shifted. So there's two things that have happened. We have shifted the green parabola to get the blue one. Okay, so here's some line. That's where the maximum is. And we've shifted. Okay, the green parabola's maximum is on this black axis. We've shifted the dashed red curve. And we've also added a constant to the blue parabola to lift it up a little bit. Well, they're both parabolas though, so they both look very simple. So what I'm going to try to do is I'm going to try to manipulate things so that the exponent of I naught looks as similar as possible to the exponent of IB. So first, where does the exponent of IB peak? So let's work out the peak of the exponent of I of B. Well, that's very easy. We just say d by dx of minus alpha over 2x squared plus bx is equal to 0. And if we take the derivative, the first term is minus alpha x, the second term is b. So we learn this peaks when x is equal to b over alpha. So good. The first thing I can do is I can introduce a new variable. So introduce a new variable. And this new variable x prime, x will be equal to x prime plus b over alpha. So if the exponent of I of b peaks when x is equal to b of alpha, it means the exponent of I of b peaks at x prime is equal to 0, because x prime equal to 0 is x is equal to b over alpha. So in terms of the x primed variable, the exponent of I of b is peaking at the same place as the exponent of I of naught. So this suggests that it may be interesting to rewrite I of b in terms of x primed. So let's do that. Let's rewrite I of b in terms of x prime. So the first thing is, well, dx will be equal to dx prime because x and x prime differ only by shifting by a constant. So that's good. So now what does I of b look like? Well, I of b will be equal to, we will have an integral dx prime from minus infinity to infinity. Good. So why do we run from minus infinity to infinity? Well, when x is infinity, x prime is infinity, and when x is minus infinity, x prime is minus infinity. Good. And then we've got e to the power of what? Well, we've got minus alpha over 2x squared plus bx. And that is, of course, minus alpha over 2. And we know what x is. X is just x prime plus b over alpha. That's squared plus b. And x is just x prime plus b over alpha. Let's just multiply out these brackets. Well, that first bracket that's squared is very easy to multiply out. So we'll get a minus alpha over 2 times x prime squared. The cross term will come with a factor of 2, which will cancel the 1 over 2 up front. And it looks like we'll get a negative. We will have x primed b over alpha. So that'll cancel. And the 2 will cancel with the 2. And then finally, we've got the last term, which would have given us a b squared over alpha squared. So, oh, and this shouldn't be a plus. It should be a minus. They're all negative. Good. So we'll get minus, we'll have b squared. Then it would have been over alpha squared, but that cancels with the alpha up front. So we'll just get over alpha. And there's a 2 because we've got 1 over 2 multiplying it. And then from the second bracket, if we multiply that out, we've got plus bx primed plus b squared over alpha. So what you see is, first of all, the minus x prime b cancels with the bx prime. So those two cancel completely. And then these two terms can be added. So what we land up getting is minus alpha over 2 x prime squared. And then we've got the minus b squared over 2 alpha plus b squared over 2 alpha becomes plus b squared over 2 alpha. So I of b written in terms of the new variables is minus alpha over 2 x prime squared plus b squared over 2 alpha. Great. And what we'll do next is let's try to simplify, or let's try to evaluate I of b.